Now, generally in simulation, probability is what is very, very important, because when you are simulating, you are not sure of the outcome. You can always say, okay, you want to give an instance. If this should happen, then this will occur. Then if this should not if this will not happen, then this will not occur. So once you are simulating, you are assuming that, okay, if I should give this guy 50,000 for instance, then this guy will buy something worth of 50,000. But if I should give this guy 100,000, then he has separate option. Now simulation, because all has to do with what? Business mathematics also. So simulation is like going back to your economics and looking at the situation where we call what opportunity cost and scale of preference. This set of subtopics in economics also help in simulating. Once you are simulating, you are not sure of an aspect. You are only assuming. That's why we have using probability distribution. From your cumulative frequency, you can able to get a random number. Then we also have another question. Using the multiplicative conversion method, generate a sequence of random integer numbers, giving the generator as Rn, which stands for random number A, the first. Then we have R base n minus 1 modulo n, and we are told where n is equals to 100, A is equals to 35, which is the initial, and our starting point is what? Is 57. Now we are told to generate a sequence of random number. Now, given the formula, we have Rn, A R base n minus 1 modulo n. Now, R base n, when n is equals to what? When n is equals to 1, we have A. What is A? 35. We have R. N is what? 1. So we have 1 minus 1 modulo. We are told that our M is what? Is 100. So this is what Rn equals to, into brackets, 35 R what? R base O. So modulo 100. Now our R initial is equals to what? 57. So we have 35 times 57 modulo 100. Then you multiply the starting initial. 35 times 57 will give us 1995. Then modulo 100. Then you divide. By the time you divide, you have to write the remainder. So this will give us 19 remainder what? So we have 19 remainder 90 what? 5. So it is the remainder that you are going to write, which is equals to what? 95. So the second one, we continue like that, since we are asked to what? Generate random numbers. So we have solved for when R is equals to what? 1. That is when n is equals to 1. Our R1 is what? 95. Now let's move on to when n is equals to 2. N is equals to 2. We have R2 equals to, into brackets, 35. When N is equals to 2, we have 35. R is 2 minus 1. We have modulo 100. So this gives us 35 R1 modulo 100. Recall our R1 is equal to what? Now 95. So we say what? We have 35 times 95 modulo what? 100. So this will give us 3325 modulo what? 100. You divide 3325 by what? 100, you are going to have what? 33.25, which is equals to 33 remainder what? 25, which will give us 25 mod 100. So our R2 is equals to what? 25. Now we go again. When N is equals to 3, we have R3 equals to 35 R3 minus 1 modulo 100. So this is 35, that is R2 modulo 100. So what is R2? R2 is equals to what? 25. So we have 35 times what? R2, 25 modulo 100. So this will give us 875 modulo 100. So you go again, you say 875 divided by what? 100, which will give us 8.75. So we say we have 8.75. Then this is, you write again that 75 mod what? 100. So our R3 is equal to what? 75. Now all we have to do is to what? Continue to reach what? R10, and you can practice it. Just follow the same format and you move on like that. Now the second B3B part question says, using the mean square, generate a 4-digit random number using 1, 2, 3, 4 as what? As start. Now we are given a starting point. Says we should using mean square method. I'll rub this, then we do you square the initial, then at the end of the day, after your resulted answer, you add few zeros, then you pick the middle number and what? Square it. That's why it's called what? Mean square. You square your what? Your middle digit by what? Adding zeros to it. Now I'm going to give you a step-by-step guideline on how you are to do this. Now for your arrow, initially you square the what? 1, 2, 3, 4 raised power what? 2. Then the 1, 2, 3, 4 raised power 2 will give us 1, 5, 2, 2, 7, 5, 6. Then you add leading 0 to balance it, so that you get your what? Your middle number. So now this will give us 0, 1, 5, 2, 2, 7, 5, 6. Now look at this. Take the middle number. This is 2, 2. So we have 5, 2, 2, 7 as the what? As the next digit. So we have to take the middle digits. The middle digit is 5, 2, 7. So we square the middle digits again. So we make that one our what? R1. since we have, okay, here will be our R1, then let's call this what? R2, because the R is the what? Is the initial. So our resultant answer will give us the what? The R1. Now, R2, we are taking the what? The middle digit. I told you earlier on that what? In mean square means what? Taking the middle digit, square it, then from there you generate your what? Your random number. So you have 5227, then raised power what? 2.